In this lesson, I'll show you two examples on how to solve a quadratic inequality. The steps to doing this are outlined over here, and we'll refer back to them as we do each question. Starting with question 1, they want us to solve and graph the solution x to the power of 2 minus x is greater than 20. The first thing that you want to do, according to step number 1, is express your function where you have f of x is greater than 0 or f of x is less than 0. So if we take this 20, which is positive, over to the other side, we'll end up with x to the power of 2 minus x minus 20. All of the left side is greater than 0, and step number 1 is accomplished. In step number 2, they want us to solve the equation. This right here is a quadratic, and what we can do is factor by trial and error. What two numbers multiply to negative 20 and add to negative 1? The answer to that would be 5 and negative 4. So we can rewrite this part as x minus 5 and x plus 4. The left side is greater than 0, and according to step number 2, we solve. So we will set this equal to 0. This gives us x is equal to 5 and x is equal to negative 4. Once we have found these very important numbers, these critical numbers, we can move on to step 3, which says locate the boundary points on a number line. So I'll create a number line for you. This yellow line represents the number line, and we have negative 4 that's over here, and positive 5, let's say, is over here. This tells us that we have three parts. We have negative infinity to negative 4 as one of our boundaries, negative 4 to 5 as another, and positive 5 to positive infinity as another. In step number 4, they say choose one test value within each interval and evaluate f at that number. So let's start with between negative 4 and positive 5. A number between negative 4 and positive 5 is 0. Let's substitute 0 into our function. And for this, you can even create a table. Most often, people do create tables here. So we have negative infinity to 4. We have negative 4 to positive 5. And we have positive 5 to positive infinity. If we choose, let's say, number 0, and we substitute 0 into here and into here, we'll end up with an answer of negative 20. This means that all values between negative 4 and 5 will result in negative numbers, so I'll put a negative. Or in other words, f at x is less than 0 between negative 4 and 5. Let's try a number that's less than negative 4. Say we put negative 5. If I put negative 5 here, we end up with negative 5 to the power of 2, which is 25. Negative 5 here gives us negative 5, which is positive 5, that's 30. 30 minus 20 is 10, that's a positive number. So f at x is always greater than 0 in this particular boundary. And similarly, if I put a number that's greater than 5 into here, let's say positive 10, I'll get positive numbers again. So our conclusion is f at x is greater than 0 when x is greater than 5. Now that we finished step 4, we have to write the solution set selecting the intervals or intervals that satisfy the given inequality. Remember, our inequality was this function is greater than 0. When does that happen? Well, it happens here and it happens here. So we'll write down that our solution set is negative infinity to 4, and we'll use this U symbol, union, which represents or, the condition, the boundary 5 and infinity. Our final step, according to this question, is to graph the solution. So if we graph x to the power of 2 minus x minus 20, you should end up with a parabola that looks like this. There it is. And we know that the function is greater than 0 over here and over here. It's less than 0 between the bounds negative 4 and 5. And so there you have it. That is how to solve question number 1. If you'd like to see the answer to question number 2, feel free to watch question 2 of this series. We'll see you soon.